Welcome to my presentation, Epistemologies of the Digital Medieval. My name is Tobias Hodel and I teach at the University of Bern. Within the next 15 minutes, I would like to do a short but rather deep dive into the world of machine learning. Therefore, I would like to start with the assumption that we are now in the age of artificial intelligence. You are probably familiar with ChatGPT now, and you probably also start using it for working on your source material. In this example I'm showing you on the screen, I use ChatGPT to basically create a regesta, a short summary of a document I've been working on at the time. And the result is quite stunning. Now, what does this mean if you can use this form of artificial intelligence, or as I mentioned, more specifically of machine learning, or even more specifically, deep learning? It means that we have to start thinking about the grand masses, the source material that we're working on, and that we are also relying on to build our models. Because if we're using deep learning, we use something that is called a model. We create a representation of the world in a very narrow fashion that is only consisting of words in some cases, or only consisting of a visual representation that would be characters or even whole documents. Now, if we use this technology, we should not only be familiar with the technological background, but also of what this means with regards to these processes. And in deep learning, the process that we're mostly relying on is called training. So all the time we are creating a model, we use training. And for this training, we use material that is similar to what we are interested in. At the same time, if we are using this material as medievalists, we are encountered with several challenges. We usually deal with a not normalized language, so the way stuff is spelled is basically completely independent of the semantics behind it. Abbreviations is a huge task, because we need to deal somehow with it. If you have a look at this specific example from Königsfelden Abbey, I will be using examples from this abbey throughout the whole talk, we'll see that it's basically full of abbreviations, and we have to, on the one hand, deal with that in the way of an expansion, but at the same time we have to think about what does it mean if we expand such abbreviations. Also, we have to deal with questions of loss. We only have a certain set of documents that are here with us today, but there are many others that we lost on the way to that. And as a more specific problem, we have to deal with complex layouts. And this is still a huge problem for computers. Now, let's try to dive in and focus on the tasks at hand. I will focus on 4 specific tasks, not because they are the most important, but I think these are 4 tasks most of the people that are working on medieval documents that they encounter at one point or another. Let's start with text recognition. This is one of the main tasks we're dealing with. Transcription has been a task of medievalists for the past centuries, and it's getting more and more automated. At the moment, we encounter basically an explosion of opportunities, of possibilities. We have different engines that we can be using, like HDR Plus or Pylaya, that are within Transcribus available. We have Kraken, that is within the eScriptorium framework there, or we can use Tesseract or Trocker or a lot of other engines. That means we are currently in the stage that we can, or we are getting more and more in the stage that we can use so-called general models that have been trained on vast masses of documents and that give quite impressive results. This is one of the open source models that I'm currently working on. We're not in an ideal state at the moment with this 10% character error rate, but this is also one of the problems I will be getting back to if we're talking about abbreviations. If you're using, for example, a model that is available within Transcribus, the results are slightly better. So you see the direction is rather clear that the automatic processing of text is one of the future givens that we can rely on. But this is only a first step. This is only text that we are creating. But usually as historians, as literary scholars, as codicologists, we are interested also in the dependencies within the text. We want to know what is the text about. And for this, we use a second approach. And as text recognition, also this natural language processing is more and more relying on this so-called deep learning. So here we're using a technology that creates so-called language models, which is nothing else than the idea to represent the language in a vector space. So we create a model that is based on vast masses of already transcribed documents, and we can then apply it to similar documents and see if there are similarities, if there are huge differences. And this language model is basically the most important part for the ensuing task, for that I will go into detail a bit later. Language model is quite an abstract concept, so let me give you a brief example here. This is also relying on the Königsfelden documents. Here we played around with the homonym Stadt, German for standing or the city. So either one you want to refer to, it's written completely similarly, STAT. But the meaning, of course, is completely divergent. Now, what you can see is that within this language model, depending on the context, the position of this Stadt is different. That means we have a representation of this one single word within this huge vector space. We try to visualize it here in 3 dimensions, but actually we're relying on about 1000 dimensions to calculate that. And now the dots, they all, that you can see on your screen, they all represent one representation of this dot with a different context. And you see some clusters. Part of the dot that are referring to the city, they are clustered together. Another part is the standing cluster, and the red dot is of particular interest because it's referring to the verbal use of Stadt, standing, but in the sense of standing in a book. So even this notion or this difference can be understood in this vector space. But keep in mind, what we did is basically a reduction of 1000 dimensions down to 3 dimensions. So we lost in this process quite a lot of information. So don't rely too much on the visual 3D representation of that. The pure math, the tasks are usually done on the 1000 dimension vector space. But why should we do that in the first place? This is the correct question to ask. It's for information extraction. And one typical information extraction task would be so-called named entity recognition. So the recognition of person names, place names, and organization, which is the most typical task. For this task, we rely on the FLAIR framework, which is an open source framework, and also for the language model, we rely on the same framework. Based on this, we can create so-called taggers. What does this mean? We do have, for example, scholarly editions with annotated data, with named entities annotated, and we use that for the training process and create these models. The results, this is just quantification, which doesn't say that much, but indicates that the results are pretty usable. What does this mean exactly? If we're looking at the example here, we had to think about, and this is already the first thought about the epistemological question, we had to think about how do we tag these entities. And for the Königsfelden corpus, what we did is we tried to make quite exhaustive spans, coming from the idea that we are not so sure of what has been considered part of the name. So we decided to take the longest possible span, what we could understand as part of a name. In that sense also, of course, we said that we actually don't really know what the name in medieval times is. But based on this span, the training process runs and the model gets created. That means for this specific tagger, for this model, the whole span is considered part of this name, inclusive here the Herr, and including here also the burger to Waldshut, for example. This is of course highly debatable, and this is basically the direction I want to go in this discussion. Of course, named entities are interesting. It's a bit similar to what we're finding in indexes in scholarly editions, for example, but they should only be a first step, because the more highly interesting questions come from the relations. This is why at the moment we're going in the direction of so-called event extraction tasks. So we want to combine the entities and we want to see how the relations work within these entities. So who is referring to whom with what intention. The example I'm showing you here is from a completely different project that is more focused on early modern times, where we see how parts of the city of Basel or buildings in the city of Basel got sold or got lended to different peoples, money that got lended and buildings that acted as securities. This is the main examples that we're finding there. But here we have this basic example of how this extraction of events can work. So basically we have something that is occurring and different entities that are interacting with each other. And of course this is highly interesting if we can do that on scale, because we see then also patterns on a higher level. But this also means we need to have this definition of what these specific named entities are and how they can relate to each other. What categories do exist of relations? For me, highly epistemological and methodological questions that tell us also a lot about how we understand the time that we are researching. Working. But as I said, for the discussions, what does this mean? For me, a lot of questions arise in the first place, because we need to think about what we do understand as a character, as a glyph. Of course, if we're doing transcription, we make these assumptions automatically, but we don't reflect on it most of the times. So if we use it for machine learning tasks, we should start thinking about what does it mean with regards to the models that we're building, because a model can only represent all the characters that it has learned. Same goes for glyphs or for superscripts. They need to be part of these training processes, otherwise the system will never be able to deal with it. Same goes for a name. So what do we understand as a name? How long has this span to be, or how narrow in that sense? So how do we deal with those entities? What is exactly an entity? What is an organization, or what is a place name? Especially with place names and with regards to organization, this becomes a difficult task. If I'm referring to Bochum, I might not mean the geographical location of Bochum, but rather the entity, the organization, the council that is acting on behalf of the city of Bochum. And if we're tagging, we need to take into consideration these problematic questions. Same goes for how we deal with abbreviations. Of course, it's nice if a system automatically expands abbreviations, but at the same time, it becomes a problem if we lose information about the characters used. Maybe they would refer to a specific scribe or a way documents have been copied. If we define events, that means that we understand that something has happened at this moment that is specific and that can be categorized a specific way. If we construct relations between entities, we also start doing a certain kind of identification, a certain kind of recognition that refers to a system that how we understand the medieval times. So in conclusion, this are not technical questions that some computer scientists can answer us, but only we as a community, as a digital medieval community, can decide and that we can refer to. This is going to be the task of the upcoming years if we want to truly digitize our disciplines. So let's start the conversation today. Thanks for your attention.